Okay, good day, everyone. Welcome to this live coding session in the data engineering track. My name is Hakim Naneka, and I'm your host for today. Today I'll be talking about Tensorflow 7, deploying Tensorflow models with Tensorflow 7. And right here on my left is a repo where I put all the code I'm going to use for today, and you can clone it and work on it on your end. So for today, the setup what we're going to use today is is called Kubernetes in Docker, and keeps it here. Also, it's required that you have TensorFlow and Miniconda, not Anaconda, Miniconda or Anaconda if you do, and TensorFlow installed in your local PC. So let's go into the code for today. Also, we also require you to have Docker too in your local PC for you to run this code here. Yeah, I will update this README file for you if you want to use that. So for today, I'm going to start by training a model with a simple MNIST computer vision model standard. I'll be training a model, and I'll be showing you how to deploy it on TensorFlow 7, that's Docker, then on Kubernetes using Kind. So let's start by training the model. So this is the code I'm going to use for today to train the model. Yes, and this is just me importing all the libraries, matplotlib, time. I'm going to import NumPy, TensorFlow, Keras, MNIST. I'm going to load the data. This is where I build the model using the sequential API, the layers, the dense, the convolutional layers, because this is a computer vision project, max pool, the flattening, and the dropout for regularization. Yeah, so let me just take you through the code. So I first load the data. We have the train and the test data, the images and the Y labels. Then we also have, well, I'm also printing out their shape. Then I'm going to reshape them, because if you want to feed in the model into the data set into a model, you have to reshape them, put them into a I think a 3D shape. This is what this does. So it just takes in their normal what is here, what is their normal shape, then just puts them into I think this is a 4D matrix, here. So it just concatenates this one dimension at like this one at the fourth dimension, something like that. So it just like turning into a 4D shape to be fed into the TensorFlow, the convolutional neural network. So also we're going to normalize, because it's standard because in pixels you have value from 0 to 255. Yes. And it is standard practice even in machine learning to normalize your data sets. So since we have pixel values, we're going to normalize by the highest value you can get, that is 255. And so we're going to divide. So what we get is a value between 0 and 1. And this is how all models, machine learning models, and also deep learning models operate. Yeah. Also helps to reduce overfitting. Also, you set the input shape and the number of classes. So because we are dealing with MNIST data sets here, you get numbers from 0 to 9. So there are 10. So there are 10 classes here. So from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 10. And now we're going into defining the model here. Now we're using the sequential API here, and so we can just be adding layers and max pool layers and layers on top of them using this sequential API. So what we can just do is we call the model.add and add the conv2d. So these are the number of channels, then the filters. If you understand deep learning theory, computer vision, there are filters and there are channels that you stack upon on each other that that are used to classify, and just put it in high level, they are used to in the classification. So we define the input shape, then we add the max pool. Then after the max pool, we add another layer. We add another layer to this, the same 3x3 filter, and also I forgot to add the relu. This is an activation layer that introduces non-linearity into the system. Then we have another max pool. If you want to know, max pools, they are used to reduce the spatial, that means because after doing this, you tend to have a kind of a large box, a very like it's going to, this is just going to half the spatial, that means the height and the width, and also this is going to also reduce it also. Then you have the flattening layer, then you have the dense, the first after flattening it, you have this is your standard MLP, multilinear perception. This is your dense, then your dropouts. This is mostly is going to reduce overfitting. That's what the movie does. And this is another dense layer that is with 10 neurons in it because of the number of classes. We have the softmax. This softmax is there because we have 10 classes. One, if there are just two classes, you can use the sigmoid function, but since there are 10, you use the softmax. And what we're going to get out is probabilities. Probability of it being 1, 2, 3, 4 to 9. Sorry, from 0 to 9. So that's what you're going to get. Then we compile the model. We call the model compile method. And use the for this just standard model, the Adam and the sparse categorical cross entropy loss, because we are using 10 classes here. Then we're just using accuracy. Then we fit with 10 epochs and a bar size of 128, and we evaluate and print out the accuracy. Now, I think the most important thing here I need to note down is this. Note out here is this. Even if you can comment this out, you can comment this out, but I won't do that. It's not needed now in this code. So this is where it's important. After training your model to be used for the TensorFlow 7 Docker image, you need to save your model using this model.save, and it saves it in this file part here. Yeah, so this is just this repo here. This is just this repo here with all this code. I just cloned it. And so I've saved my model here in this image classifier. And so this is what you just get. You have these assets, then the variables, then this is just like what TensorFlow 7, this is what TensorFlow saves your model as, and your TensorFlow 7 Docker image reads it in. So yeah, this is all the code for training the model, and I've already run the training because it's going to take a lot of time also to train it. But this is a CPU. If this virtual machine I'm using is just has a CPU, if it has a GPU, then maybe I would have run it because it's going to be faster. So on your end, you can just run this code python model.py. So it's just going to help you, it's going to train your model for you. Yeah, just python model.py, and it will start your training for you. Yeah. So I'm not going to do that now just to save time. So let's move on to the next thing, which is actually, yeah, I've already trained the model and I've saved it in a save model format. This is what TensorFlow 7 understands, a save model format. That's what I did here. Now, so I'm just going to build, okay, I want to show you the Docker file now. I understand that you've taken your data engineering track, and so you understand some of these terms, what a Docker file is, what a Docker image is, and a Docker container is. I'm just going to elaborate again. So in a Docker hub, there's a kind of file or an image that is called TensorFlow/7. This is from Google itself. That's TensorFlow. TensorFlow is under Google. So this is from Google itself, their standard image. So what we're going to do now, we're going to download that image and also modify it. So we're going to copy our image, our model, save model into this. These are standards in the TensorFlow 7. I think I wish I can pull up the the their what do you call it, their documentation. But this is a standard format. In the image itself, they require you to copy your image, your model, into this models folder in the Docker image. That's so I'm naming it also image classifier, and this /1 means, you know, after some time, your model, there's something called where you have to retrain. You have more data, or your model is not performing well, something like that. So you can always retrain. And when you retrain, you might want to put a different number, but it's still the same model, if you get what I mean. So, and now we're going to assign an environment argument called model name. This model name is used by the TensorFlow 7 image to identify which model you want to work, you want to actually deploy. You get so, you also you may be in a company that has different kind of models. You might have NLP models, might have just machine learning models like maybe XGBoost for classification and all. So TensorFlow 7 also allows you that these are the benefits of TensorFlow 7. Allows you to have different models and also different versions of those models. Yet, so you can also be updating your models at the back and just changing these parameters, and you have the new model up and running. So now that I've done that, I've explained the Docker file. Now what we just need to do, so yeah, this is their documentation for this will come in handy later for us. So let me just put that to the side and go back to the repo. Okay. Yeah. So now what I'm going to do is I'm going to now build the image. So you have a Docker file. Now you have to build that Docker file, convert that file to an image. So what I just do, I'll just run Docker build my in my terminal, and I'm naming that image TF7 classifier version 01. And this dot here means that it is in the current directory. So this Docker file is in the current directory that I'm working in. The current directory I'm working in. So I just build it. So I've already done this before. So it's going to load the image that is already just fast here. It's going to load it from my cache, and it's going to build the Docker image. Now that I have the Docker image running, so let me just give you like a background on TensorFlow 7. So TensorFlow 7 has the ability to host different endpoints. So endpoint as in you have the REST API and you have the gRPC. So the REST API is what we all know. If you have experience as backend engineers, media backend engineers, there are people that have worked with HTTP, often front end. You know that REST API REST is the kind of protocol we use in all web applications that we have. We have methods like the get, the post, the delete, the put, And the most important thing about REST API is that the payloads as in the kind of the messages, the parameters, everything, the payloads in the request are mostly in JSON format. So I think this is REST API is very common. And now for the gRPC, it's practically Google initiative, Google produced, and maybe they saw the fact that the payloads in their JSON is kind of, maybe say, high latency. So they were looking for a way to provide low latency and also smaller payloads than REST. So they developed the gRPC, but today I'm not going to talk about this because this is kind of more complicated, because when you're working with gRPC, you don't train your model the same way we train our model here. There are different ways. It has to be lightweight. That's why it's gRPC. So there's a different way of training your model, saving your model, and also running the predictions with that model. So I'll give you that maybe as an assignment. Maybe you can do your research on it and check out what it means. So let's move on. So right now, what I'm going to do now is going to run the Docker image and get the container running to get. So this is what this command does. So I'm going to explain the parameters here. So I'm going to run it interactively. That's what IT means, interactively. So when I close this image, when I close this container, when I like end the process, it should remove the container from running in the background. And now this is the most important part, the ports. So Docker containers work with ports. Yet so I'm now the think I need to add that for the gRPC, it works with a different port. I think that is 8500. And for REST API, it works with 8501. So that is why I'm connecting this is my local port to the port in the Docker container. So I'm just like connecting their ports 8501 to 8501 in the Docker image. And I'm using Docker container, I'm using the image that I've built before to run this container. That's it. So yes, I think now the the Docker container is running, and I want to make my prediction now. So I think I need SSH to, sorry, let me just get this is a virtual machine I'm using here, so I have to SSH to it and get things running. So sorry for that. Yeah. So I'm going to SSH to the my virtual machine that's running on Azure, and I'm going to okay. So I'm going to now. I need to I forgot here too, but I need to convert to change my Docker environment to, sorry, not my Docker environment, my Conda environment to TensorFlow, where I have the packages in. Yeah. So now I've gone into the TF environment. And now, since I have the image, the Docker container running in background, now I want to make a prediction. So like I have actual images of numbers, and I want to make predictions with that model that is being hosted on that Docker container. All right. So now this is the Python package for this is predict.py. It's still in that um, folder. And so I'll just import matplotlib requests and JSON. Remember, this is how I make my request with the request package, Python request package, and with JSON, because the payload that REST APIs work with is JSON. So I need the JSON package, NumPy, and to load my test data. So now here I'm loading the test data with the load data method from the MNIST class, and I reshape it. I do my preprocessing again because the model was trained with those parameters. So I reshape and I also normalize. Yeah. If I don't normalize the image, the model won't work fine because it's trained with values from 0 to 1. Also, this is just for me to this is just a test example, but normally in your system or in system we work with, you're going to upload that image. So you have to, in place of this, you're going to have to get that image, process it. You have to load the image, process it, then normalize it. You have to put it in the same format that you trained the data with, you trained the model with, okay? And now this is the most important part. To make calls using this Docker image running, this Docker container running here, there's a format for it. So let me just go back to that TensorFlow 7 partner fast. It's here. So this is so now to make calls, there's a way to 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 put your request in. There's a format in which you put your request, and this is it. So you have your, I think I also have it here too in my GitHub repo for you. Yeah, so you need your hosts. That is your, since this is not on like a on a cloud platform. It's this is my local host, and also the port. Remember we initialized it with 8501. Now, like I said, the version you're working with, like I put in the models, like where we remember where where we moved, we copied our model, save model into this part here. So that's what we're using. So the models, the model name, and also the verb. That's the most important part here, the verb, because we're going to make a prediction. We need to use the predict endpoint of the container. So this is the way to build your URL. Yeah, the host, the port, the model name that you used in your environment here, and the predict, the verb you're using. So there are different verbs here. I think from the sorry for that, from their documentation, I think there are like three here. If I can get them, the request formats. Yeah. So there's the predict, and I think there's the classify and regress. But I don't think. Yes. Now there's the classify and regress, and now there's the predict it API. That's what we're using here. But let me not digress into that now. Okay. All right. So now that we have we have all that, now we can just make our request, our prediction request. And so we have to put it in this format. Also, it's also in their documentation. Like if you check it out there are these requirements that you need your request to be, your payload to be in. This is a default value, and now this is where it is your instances. These are okay. These instances, this is a method. These are the images, actually, the actual images, or the numpy arrays with the data you want to make prediction on. And now, so you have to convert them to list, because um, the endpoint doesn't work with numpy arrays. You need them in standard list format. So that's why I'm calling the toList method of the numpy object here on this object here. So this is it. These are the headers. These are also optional tags too that you add to your request. Now this is where the actual request is being made. You need the pull. This is a post request, because you are sending in data. I think there are people here that have worked with in the back end, and they know that this is how I'm trying to pull out where the actual request is. But I think this is the predict request, and this is how they said the request should be like. But let's continue. And so now I'm going to make the request. I'm going to get the prediction. So in the predictions, you just have to select there's a response format. You have to get the text, and you have to get the predictions. They are all in documentation if you look at it, and you return the predictions. Now I'm calling this method, this function here, with just three of these test variables, these test images. I'm just calling it from 0 to 3, because I'm just going to be 3. This 0 to 4 will not go to 4, to stop at 3. So they're just going to be, I think, 3. Okay, it's going to be 4. Actually, they're going to be 4 test examples here, and I'm going to make my prediction on all of them. I'm going to show you the true values, that is their actual values, and they are also their predicted values. Okay, this np.argmax here means that I'm getting the predictions, they return values from 0 to 1. Those are probabilities. So now this argmax takes the argument with the highest prediction, like probability. So the highest probability. So the one with the highest probability is actually the prediction that the model has made. So let me just run this. So I'm going to run the predictions now with this. python predict.py. Okay, sorry, I'm not in the desired directory. Always remember. So this is where the actual predict.py script is. All right. So now I'm going to make a call to this container here and see what it's going to give me. And it's loading all the now. So this is where it gets. This is where the actual outputs are predicted. But maybe if you are working in a website, you're going to print out. You're going to print out the predicted value. But here for this test, for this demo, I'm just like printing out the outputs for everyone. So here we can see that I'm making like 4 calls to this endpoint. There are 4 calls, 4 examples, 4 test examples, and now I'm printing out the true value. So the value that was in, we're working in MNIST, they're actually like black and white numbers. So the value that was here is there was actually 7, and what it predicted was 7. So we found out that even if I train the model here with just 10 epochs, the model still like was good enough to know that the the value that was sent to it, and it also predicted it accurately. So the accuracy is quite good for a model built with just 10 epochs. So that is that for TensorFlow 7. Now I want to, like, in actual real world sense, you have this Docker image or this TensorFlow 7 running in Kubernetes cluster in the cloud. So everything I'm doing here is all local. So I'm using my PC to run everything. You can also like deploy this on a Kubernetes cluster, actual Kubernetes cluster, and make predictions from your phone or from anywhere into that cluster, because it's going to have an IP. But let me just show you how to deploy this TensorFlow 7 on Kubernetes with kind. Okay, so now what I'm going to now is Kubernetes and Docker. So I've given you the link here on how to set up kind on your local PC. You can, if you're using whatever you're using, I'm using Linux. I copied this, and I have kind installed in my local PC now. So now I have kind set up in my local PC. Yeah, and now I want to load. Okay, let me explain. So kind is a kind of way of testing your Kubernetes deployment on your local PC before carrying it to the actual cloud services. Yeah. So now I want to this Docker image I am using now. I want to load it into a Kubernetes cluster. Now, for me to get it in Kubernetes cluster, I have to load the image into kind itself. So I'm going to copy this command. This command just loads this TF7 classifier image that I've built here, just loading it into the kind cluster for me to use to make to build the pod and the deployment. I'll get into that shortly, but let me just show you how to load the image into kind. So I've already done this before, and it's showing me that the image is already present in my kind cluster. Also, you can also, like, in your own case, instead of doing this, if you are done with building your image, you can now upload it into Docker Hub. I didn't go into that stress. If you don't want to load the image, you can also not load the image. You can actually upload your Docker image into Docker Hub, then kind or Kubernetes will load in that Docker image from Docker Hub for you and use it to build the pod and the service. So now, I think we've done the introduction to Kubernetes class or the demo from last week or last 2 weeks. And I'm sure you will have like a background knowledge of what Kubernetes is, what pods are, what deployments are, what services are. But I'll also like try my best to explain what they are to you. So Now I want to show you what this I want to go into and also hope you understand what kubectl does. Is like is a way of you interacting with your Kubernetes cluster with the command line. So that was kubectl just is just command line. Just using command line to interact with your Kubernetes cluster. That's what kubectl is, and those are the ways you can interact with your Kubernetes cluster. So I want to like now deploy this TensorFlow 7 service in or model in Kubernetes, still using TensorFlow 7 images. That's the Docker image. So now, you know that you have to build your YAML file. You have the deployment and your service. This is the way for you that you build your pods and your services. Right? So I this is the YAML file. I've built the YAML file before, so you can just take a look at it and see what's going on. So I have the deployment file. This is the format for you to build your deployment file. Now I want to explain like what these terms are. So the name of the deployment is going to be TF7 classifier. Yeah. Okay. Let me start from here. So for your pod to run, you need a Docker container or a Docker image, right? For you to build it, to have a pod, to build a pod. Now I'm now like naming. This is the name of the image in the pod, and this is the name of the image that I have loaded into the kind cluster. I don't know, and maybe I'm going too fast, but this is just standard. This is just a standard deployment YAML file for your Kubernetes cluster. And so this is the name of your pod. This app metadata labels app. This is where you name your pod. Now, for a deployment is a group of pods. So now you want to know which of these pods should be in a deployment, and this is how you set it. You set it using this selector tag match labels. You match the pods with with the name TF7 classifier. You have named your pod TF7 classifier. Now a group of pods is deployment, and this is how it knows these pods are in the deployment. Hope that is clear. Also, I forgot to say that you also have to determine, you have to set your limits for a pod or for a container. So you have to set the memory and the actual CPU it takes from your local PC. So I set this at 128 I think this is MB megabytes, and this is half of your CPU of one CPU of one CPU. The time is kind of confusing, but what is 500 M can also be 0.5. It's also means just half of your virtual CPU. That's what it means. Virtual CPU or your CPU, you get. So that's just what it is. And now the container port you're working with is port 8501 because we're using Docker, we're using TensorFlow 7. We're using TensorFlow 7 at the back of like this Docker image is built on TensorFlow 7, and the REST API works with 8501. Okay, so now we can just build our image. So build our start our deployment. Let me just say that start our deployment. Now we can see that the pod has started, so we can just see how it's going by running think kubectl get pods. Now we see that the status is running, that is running perfectly fine. I think we can also do kubectl get deployments. So deployments, yeah. Okay, so it says that the TensorFlow 7 classifier or TF7 classifier deployment is up and running. All right, so now you know that the deployment is there. I mean, the pod is there. Now you need to communicate with that pod, and to communicate with your pods, or to communicate with your pod, you use the service. Now you need a service and a service deployment, something like let's just call it a service. Is standard in Kubernetes. So this service is what helps us communicate with the actual pods in the cluster. So now we have to build this with a separate YAML file. So this is the way to build a service with YAML files, with a YAML file, and this is how you determine if it's a service. If I can get the deployments, you also see that we name this a deployment, but for service, you have to name it a service. Sorry. So now the name of this service is TF7 service, SVC. Yeah. And now you need to tell it this service. This is what you're going to communicate. These are the pods you're communicating with. And the name of the pod or the deployment you're communicating with is TF7 classifier that we just built now. Sorry. And now if you want to communicate with your service, you communicate to your service with port 80 or port 8080 or like whatever you want to determine. And you also want to tell it what is the port of the pod or the deployment you're working with, and that is 8501. Yeah, so this is what a service does. It's just a way, it's where you send in your request through the service. And also there are other things, but this is just a simple deployment. Actually, I think you need to have a node port that you communicate with, that communicates with the service and then communicates with the pod, because you have your cluster secured. But I won't dive into that because this is just a simple local deployment. All right, so I've defined my service YAML file, and now I just need to create the service. To create the service, you just copy this command, kubectl apply. The file, where the YAML file is in kube-config folder, and the YAML file is service or YAML file. Yeah. And so if you run this, your service will be created. Now, to check if your service is created, I'm sure you guys know this, is kubectl gets service, and we see that now I need to let you know that this is a cluster IP kind of service, which means that it doesn't have an external IP address. Now, when you are deploying in the cloud, you need to have something they call, I think, the node port, and that node port will have an external IP. But since this is not a cloud Kubernetes service, this is just a local for testing. You have to now, for you to communicate with this service, you now have to do what they call port forwarding. Okay, I hope like what I explained is it's understandable. Let me explain it again. What I'm saying is that ideally you can't communicate with this cluster IP. To communicate with this, you need to have a node port. Now, since this is not a cloud service, you can't have a node port with an external IP. Yeah. So what you have to do now, because this is for testing, you need to port forward from your local PC, port forward from a port in your local PC to port 80 of this service. I hope this is clear, because okay, let me just run this out. Let me just run this now for you. So now this command, it port forwards this service to your local PC port 8080. So now if you want to access this model running in the background, I'm going to modify that predict.py file to port 8080, because we are now communicating with it through port 8080, not port 80, because you can't get port 80 because it's not accessible. Okay. Now I'm port forwarding. Say port service not found. Let me get the service. Okay, sorry. Classifier is TF7 service. Sorry for that. I'll need to TF7 service SVC. All right, now we see that we can communicate with that pod now directly. Like if you send a request to port 8080 of a local PC, you can now communicate with that pod that deployment that you built up. So now you can send in a request to port 8080. You have to change this to port 8080. Okay, let me leave it at that and show you that it's not going to work. So if I run that predict.py file now, if I run that python predict.py, it shouldn't work because it can't make a connection to port 8501 because the 8501 is not open, it's not available to take requests. What is available to take requests is port 8080 because I port forwarded my local PC port 8080 to that service, and it's that service that communicates with the pod or the deployment. Hope that is clear now. So now I have to change this to port 8080 and save. Now that is saved, now if I try to make a prediction, now it has given me a prediction. Hope you understand now that this is not just a Docker image. Before I was just working with a Docker container and I ported that Docker container to my local PC. Now we're working with a standard Kubernetes cluster. And we know that there are benefits of using Kubernetes cluster because it handles requests faster because it will replicate pods. So it's kind of like how you can bring your model into production, where you can, like, if you are like ChatGPT now, OpenAI now, you're handling like 1 million requests per day. You can't just have a container running. So you need to have a Kubernetes cluster that helps you replicate your pods, helps you auto scale, it helps you heal, because if a pod kind of has an error or kind of fails or kind of cannot handle requests, Kubernetes helps you restart that pod up or that service up, and it also gives this kind of security because you just need to have a node port. Like I said, this is not a standard cloud. It's not a standard cloud Kubernetes cluster. If you want to get this into a standard cloud Kubernetes cluster, you need to use something like Azure, AWS, EKS. I think in Azure it's AKS, Azure Kubernetes Service. Then in Google it's GKS. They have it standard for you. You can also build up your own Kubernetes cluster if you have the funds for that. But if you don't have the funds for that, you have to revert to standard cloud Kubernetes clusters, and that will now enable you to have an external IP which you send in requests to. So that external IP that is here is, you have to put it here. The external IP is what you replace here instead of the local host, and that port of that node or that service or that node port is what you put in as a port here that you use to make requests. So that's why Kubernetes is very, very important. Yeah, so for now, this is where I end the class for today. I don't know if there are any questions for me. For your like for your take home, you can always um try and deploy this in a cloud platform like AKS, EKS, GKS, and you can also try out KServe. KServe makes like it's easier to get up your to use a model. Okay, let me say KServe enables you to not only use TensorFlow 7. You know, here TensorFlow 7 only works with TensorFlow models. Now, KServe enables you to deploy any kind of model from sklearn to XGBoost to ONNX to TensorFlow, PyTorch into Kubernetes instead of running different YAML files, because in standard you might have to build like 4 or 5 YAML files just to get your deployment up and running. But with KServe, you just need to get one YAML file and it will help you deploy your model on Kubernetes cluster with just one YAML file. That's why KServe is very, very popular nowadays. But I don't have the opportunity to go into that because of time. And I also have the repo is going to be shared. So if you want to look into it and go more deeper into KServe and other things, and even deploy into AKS or EKS, you can do that. So I don't know if I have any, if there are any questions for me. Let me check in the chat. Okay, there are no questions. So thank you very much. It's nice having you here in this demo. I hope to see you again in the next one. Take care. Goodbye from my end.